Okay, these are the notes. I'm actually on the wrong slide. I got to go back to the beginning. For 12.1. If you look at some of the links in the bottom of the Chapter 12 module, there's some really great links there to let you see kind of how these three-dimensional figures fall apart and how they work together. I encourage you to look through those as well. Again, there are links in the bottom of the Chapter 12 module. There are a couple of vocabulary words. A base in a rectangular prism, that's going to be hard to tell. I will tell you what the base is, but you'll have a base. Maybe that's better here. In this one, the pentagon is the base. And then all these rectangles that are kind of connecting the two pentagons, they are called the lateral faces. So the rectangles are the lateral faces, the pentagons are the bases. The lateral edge, that might be a little hard to see here. The lateral edge is actually here where the lateral edges meet. A base edge is just the edges of the base. I have some vocabulary here. In altitude, it's the height. It's the segment joining the two base planes and perpendicular to both. In a right prism, which is what we're going to be dealing with, a lateral edge is an altitude. They're the same thing. The bases are congruent polygons. The lateral faces I talked to you about and lateral edges are here. And you'll see us kind of using some of that vocabulary as we go through. A right prism simply means that the bases are directly one on top of the other one, that if you connected the corresponding vertices of the bases, that it would be a perpendicular line. It would be perpendicular to the bases. There is another one called an oblique prism. We don't really work with those. So when we say like a right triangular prism, that's meaning that the lateral faces are perpendicular to the base. So over here, I identified ABCD as the base for you. The lateral area is the sum of the areas of all the lateral faces. And I outlined some lateral faces for you here in blue and in red, and hopefully you'll see some more. So I'd like you to push pause and try to determine what the lateral area would be. All right, when you did that, you should have gotten there was a 2x4 rectangle, another 2x4. That's the blue one and the corresponding one back here. The red one is a 2x6 and the corresponding one here. And when you add all those together, you get 40. But what you'll see here is you can do that every time and just find the area of all the rectangles and add them together. I was looking to kind of generalize it more. So this had a common factor of 2. I factored that out. And I'm left with 4 plus 4 plus 6 plus 6. And if you look up here, 4, 6, 4, 6, that's actually the perimeter of the base. And the 2 is the height. So we can generalize the formula to be lateral area is perimeter of the base times the height. Now, this is the same figure. I just outlined the base in green. Okay? So the total area would be all the different pieces, if you think of a box, all the different pieces of cardboard you would need to make this. So you're going to take the lateral area, because you're going to need that, and we found out that was 40. And then we have a 4x6 rectangle here and a corresponding one on the top. So I'm going to add 2 area of the bases. So this is the area of the base, and I have 2 of those bases, one on the top and one on the bottom. Okay. And we can generalize that to be the lateral area plus 2. Capital B stands for area of the base. For the volume, we talked about this in class as well. It's looking for how many little cubes, in this case 1 centimeter by 1 centimeter by 1 centimeter cubes, would fit in here. So to figure out how many cubes, you could start by figuring out how many are on one level. So that would be 4 times 6. And then multiply by how many kind of layers of those cubes you have, which is 2. So it'd be the area of the base, which is 4 times 6. That gives us the number of cubes in the first layer, and multiplied in this case by 2, because that's how many layers I have. And we generalize that to be volume equals area of the base times the height. In the next slide, we have a triangular prism. So what I'd like you to do is push pause, try to find the lateral area, total area, and volume. So take a few moments. You can draw it out. You can draw the separate pieces if that helps, or if you want to use formulas, use what works for you. So push pause now. All right, as we look at lateral area, I did this one kind of in two different ways. In this part, I drew each lateral face, and in green, I found the areas and added them together to get 110 centimeters squared. I also could have used the formula perimeter of the base times the height, and that equals the lateral area. So the same answer, just two different ways to look at it. So kind of look what works for you. For the total area, I needed to look at one of the bases. So I have the base here, and I saw that this is a triangle, so I have to use my triangle formula. So the area of the triangle is 1/2 of 4 times 2.8, which gives me 5.6. So that's the area of one of these triangles. For total area, I need to take the lateral area. Remember, I got that up here. And I have two of those triangles. So I need to take the 5.6 I got from here and multiply it by 2, add them together, and I got 121.2 square centimeters. For the volume, again, I'm taking the area of the base, which is right here, and I multiply that by the height, 1056 centimeters cubed. All right, in the next one, I have a trapezoidal prism. This is a trapezoid here, so I'm just going to, again, ask you, work through it yourself, come back to check the answers. All right, for the lateral area, you can see my work, total area and volume. Okay. And if you have questions, you're not sure where something came from, write that down, and you can definitely email me or come and talk to me about that. The 1/2 times 4 times 6 plus 12 is coming from our area of a trapezoid, 1/2 the height multiplied by the sum of the bases, and we did that in chapter 11. In the next one, we're told a volume at cube, so cube, all sides are squares, has a volume of 8 centimeters cubed. So the length of each edge of the cube, the volume is going to equal x cubed because my length, width, and height are all the same. So x times x times x is x cubed. I know that equals 8. To find out the cube root of that, there's a button on your calculator that'll do cube root. So the cube root of 8 is 2. Some of you can reason through that logically as well. So the length of each edge of the cube is 2. To find the total area of the cube, if you think about it, it's really made of 6 squares. So what I did is I just said, okay, the area of one square is 2 times 2, and I know there are 6 of those squares making up the cube. So you'll get 24 square centimeters. In the next one, a right triangular prism. You got to be careful here. When you see the word right, that doesn't mean this is necessarily a right triangle. It just means, again, that the lateral faces are perpendicular to the base. So first thing I'm going to do is I look at this triangle. I see 5, 12, and 13. I try to figure out what kind of triangle is that. So I used converse of the Pythagorean theorem. I found out it is a right triangle with a base of 5 and a height of 12. So I know the volume equals area of the base times the height. I know the volume is 450. The area of the base is 1/2 times 5 times 12. And I simply solve that equation to get 15. In the last one, I would like you to try this one. And then come back, so push pause now. All right, I drew the base here. They said it was an isosceles right triangle, so you see I have that there. Using Pythagorean theorem, I can find this side. And I have my answers here for the different problems. So check your answers and make sure to ask any questions in class or send me an email. And that concludes 12-1.